that we know a little bit about normal distributions, let's look a little bit closer. So we talked about how to find the proportion or the percentage of data values that were within a certain range within 1, 2, or 3 standard deviations. But what if we don't want something that exact? What if we want a data value that is not within one of those standard deviations? So for any normal distribution, we need to know the mean and standard deviation, and to do this, we're also going to need to know our data value, x. And we're going to start by finding what's called the standardized score. This is often called the standardized value or the z-score. And here's our formula. Z is equal to x minus mu over sigma. We take our data value that we're looking at, subtract the mean, and divide by the standard deviation. So let's look at an example. We had previously looked at the US female height that had a mean of 65 and standard deviation of 3.5. And I want to find the standardized height of a woman who is 71 inches tall. In this case, I know the data value is 71, my mean is 65, and my standard deviation is 3.5. Sticking this into my formula, I have my data value minus the mean divided by the standard deviation. And once we work this out, we get approximately 1.71, so that would be our standardized height. This particular woman would be 1.71 standard deviations above the mean. This time I want to know the standardized height of a woman who is 5 feet tall. So once again, let's write down what we know. We have that our mean is 60, or our data value is 60, our mean is 65, and our standard deviation is 3.5. So I did go ahead and convert this to inches because we do need to make sure that everything is in the same units. I then am going to go ahead and stick things into my formula. My data value minus the mean divided by the standard deviation. And this time my standardized height is negative 1.43. So it is absolutely fine for this to be negative. It just essentially tells us that this particular woman is below average. So a negative standardized value just means you're under average, and positive would mean you're above average. So now that we've talked a little bit about that, let's start to look at the actual proportions or percentages. So I actually want to be able to find out what percentage of women are above 5 foot, or what percentage of women are below 68 inches. And while we did a rudimentary form of that, being able to move up or down by 1, 2, or 3 standard deviations, we want a general way to do this for things that aren't nice standard deviations. So there are a couple of ways to do this. One is actually tables for area that you can use, and you can also use technology, and we're going to rely a lot more on technology. And technology does give us what's called cumulative proportions. So what that means, here is my very, very rough sketch of a normal distribution, and if we give it a particular value x, the cumulative proportion gives us the proportion that's underneath that. So before we actually start doing examples, we're going to look at how to find other types of proportions. So there are 3 total types of proportions that we can do. Proportions that are less than x, proportions that are greater than x, or proportions that are between x and y. And in order to show us how to do these, we're going to go through an example. I'm going to go back to my example of US female height. We know the mean is 65, standard deviation is 3.5, and I want to know what proportion of women are shorter than 60 inches. My first advice on all of these types of problems is to start by drawing a short picture of exactly what we want. So the way we do that is we draw a rough sketch of a normal curve. The mean of 65 is right at the center, so 60 is going to be somewhere over here to the left. We want shorter than 60 inches, so we want everything less than 60. And in order to do this, like I said, we're going to look at a calculator. Here's my GeoGebra graphing calculator. I'm going to hit the 3 dots at the top right of the keyboard to get to my commands. And instead of statistics, this time I'm going to go into probability. And the probability that I want is the normal, because we're dealing with the normal distribution. In order to use this, I now need to enter 3 numbers. I start with my height, or I start with the mean height, which is 65, comma, standard deviation, 3.5, comma, the actual data value that I'm interested in, 60. And I get this 0.0766, roughly. That can also be 7.66%. And this is what the calculator always gives us, the area to the left of that data value. So anytime we want to know shorter or less than, we just type that into our calculator. And just as a reminder, we're going to use the normal command. We enter mu, sigma, and then x. Let's do another example. This time, I want to know the proportion of women taller than 68 inches. And once again, I'm going to start with a short, rough picture. I have my mean at 65, and 68 would be somewhere over here to the right. And I want taller than, so I want the bigger end of this, things to the right. Before we use this normal of the mean, standard deviation, and the data value, and we are going to use that again, but we're going to have to modify it slightly. So the commands always give us the area to the left, all of this stuff, but that's not what we want. We want the area to the right. And we're going to use the key that the area underneath this is always 1. So if I want the area on the other side, I need to do 1 minus this normal distribution. So the normal command gives me the area to the left. To get the area to the right, I need to do 1 minus. So let's look at that. Here's my calculator. I'm going to do 1 minus and hit my 3 dots. My normal's up here in the recently used, so I'll just click it. My mean is 65. My standard deviation is 3.5, and the data value that I care about is 68. So I have roughly 0.196. So my actual answer would be 0.196 or 19.6%. Let's look at one more. This time I want to find the proportion of women between 60 and 68 inches. If I draw my rough sketch of my normal curve, 65 is at the center, so 60 is over here on the left, 68 is over here on the right, and I want to know what percentage is between. And in order to do that, once again, we're going to modify our normal command on our calculator. So the normal for, let's say, 68 is x and 60 is y. In general, we want to consider the bigger number first. If I stick that into my calculator, it gives me the area all to the left of 68, which is more than I want. If I look at the normal distribution with y in my calculator with the 60, it gives me this piece, the areas that I don't want. So when we're dealing with this, we're essentially going to use our normal command on both of these data values and subtract the results. So we have normal of mu sigma x minus normal of mu sigma y. And like I said, we always do the big minus the little. So let's see how that works on the calculator. We'll click the 3 dots and select the normal command. We know our mean is 65, our standard deviation is 3.5, and the bigger of the data values is 68. Minus, we can go back in and select our normal command again. This time the mean is 65, standard deviation is 6.5, and my other data value is 60. So the proportion that's between the two is roughly 0.728. So my final result is that the proportion between 60 and 68 would be 0.728 or 72.8%. So now that we've looked at this, let's look at something slightly different, essentially going backwards. What if instead of wanting to know the proportion of women that was taller than 60 inches, I wanted to know just the tallest 2% or something like that? So let's look at something like that. So I want to know what height corresponds to the bottom 2% of women. And all of these problems are going to start the same by giving a rough sketch of a diagram. I know the mean is 65 and I want the bottom 2%. So what makes this problem different is I know that this area is 0.02 and the actual data value here is what I'm looking for. Before I had the data value and I was looking for the proportion or the percentage, now I have the percentage and I want the data value. Before, whenever we were looking with the data value and we wanted to find the percentage, we used the normal command. With these, we're going to use inverse normal. With the inverse normal command, we're going to need 3 data values: the mean, the standard deviation, and the percentage written as a decimal. So let's look at our calculator. So here's the calculator. We can click on the 3 dots. We can do a search for inverse normal, or we can go back down to probability. And we can see lots of inverse commands. We want the inverse normal. We know our mean is 65, and our standard deviation is 3.5. Oh, I forgot a comma there. 65, 3.5. And the actual percentage that we're looking at is 2%, so 0.02. So the smallest 2% would be a height of 57.8 inches. So now I have the result. Let's look at one more. This time I want to know what height corresponds to the top 5%. And once again, we're going to use our inverse normal command. So we're going to start by drawing a quick picture. This time, I don't know my data value, but I know that the top percentage here that's shaded is 5%. Just like with the normal command, inverse normal always talks about area to the left of the line. So I do have to use the fact that if this is the top 5%, it's also the bottom 95%. So when I use my inverse normal command, I need to actually refer to the 0.95 instead of the 0.05. Moving over to my calculator, I'm going to select inverse normal for my recently used. I have a mean of 65, a standard deviation of 3.5, and like I said, since we want area to the left, my percentage is 0.95. So a height of roughly 70.8. So any woman in the US that has a height of 70.8 or taller is in the tallest 5% of women.